Hello everybody, it's Crazy Logics 007 on YouTube, Crazy Logics in the forums, and everybody else just calls me Damon. Today we got a Deaf Bonce AAB-7900. It's about an 8,000 watt amp. It would be the same as the Sundown SFB 8000 and the Sound Digital 8,000 watt amps. These are all Sound Digital clones. We'll see what's wrong with this one. I think I've already peaked at this one. This seems to be a super duper popular size. That's a lot of wattage in a pretty small spot. But as with all these amps, they don't take the abuse for very long. Looks like we got some melted stuff. Yeah, melted. Let's flip this around here. That's not good. I'm gonna go through with my multimeter. I won't bore you to death, but I'm sure the power supply is dead. We'll test the outputs, see if that's okay, and we'll get this thing up out of here, and we'll start cleaning on it. Definitely going to be removing some of that. We're going to have to build some, either salvage some of these out of another amp, or make some new clips, because those are pretty toast. So I will get to getting this out of the case, and I'll be right back. Okay, just to note, besides all the screws that are taken out of the end plates to be able to pull it off, and all the screws along the perimeter, there are two longer screws right here and here in the middle. So now should be able to lift this up here, and as you can see, it's already falling apart. Put that back down there. There's a whole bunch of stuff. So this heat sink I'll have to remove these out of here, clean all this up, and hopefully salvage these. These will have to thoroughly be cleaned. We don't even want any of that carbon stuff, because that could be conductive, and that would just make it short out and die again. So all this has got to be cleaned when we go to put the heat sink back in. Let's get this out here. And you can see we are fried up good. I tested and I did not find anything wrong with the outputs. So probably a voltage issue. And I know a bunch of the guys that are running these in competition right now are running some lithiums, and I'm not a fan. They seem to be blowing stuff up. We'll have to, I'll double check the outputs again now that I got them out too. I kind of did it quick because this is just a mess, and I didn't know what was shorting with stuff. But I'm going ahead and get my snips out, and I'm just going to go through all these and going ahead and bend them up and get them snipped out of here. You can see they're just falling to pieces. I mean, that, that's what we got there. So one thing I'll point out, and yeah, you can even see it here. Let's see if I can get up there real close. We're looking at this chip right here, IC3. You can see that it's got damage on it. And so IC3 is the 4227, I believe it is. It's a FET driver. So we'll have to replace that and check a couple things around there just to make sure it's okay. Some resistors and stuff that feed. That's what drives the power supply circuit here. As long as the output section survived and the two sets of rectifiers, hopefully we can get all this desoldered. I'll get my desoldering gun out. Like I said, I'm going to clip everything out that is blowed up here on both sides. All of it's got to get changed. I don't trust any of it. We'll change out this chip and clean this board and make sure we don't have any other damage. Most likely we'll have to replace all the gate drive resistors, which are, you can see that little one there, that little one there, right next to the gate legs. A little better here, maybe that little bitty sucker right there, that little bitty sucker right there. As you go along, there's another, there's another. Those should be 10 or 100 ohm or something. We'll look. I think they're 10 ohm. And so, like I said, I'm just going to go. Well, some of them are just going to fall apart for me. Some of them won't. See, like this one doesn't. So I'm just going to clip it out. This gives me some legs to grab onto with my tweezers when I desolder it from the back side, so I can just pluck these out. I'm going to do all that. Then I will clean on the board with isopropyl rubbing alcohol. And we'll try to get this cleaned up on both sides. Then I'll bring you back once that's pulled out and maybe show a little bit of the cleaning, how it looks really bad. It'll actually clean up really well. You'll be surprised. Sometimes they don't, but most of the time they do. I'll bring you back in there, and then we'll do some inspection, testing of those gate drive resistors. They're probably shot. We'll test over here, and then we'll get this all removed out, and we'll start the rebuild process. Technically, you should be able to fire it up once you replace this chip. Make sure it's good with just one transformer on each side to give it line voltage and stuff. You wouldn't have to replace you could just leave them removed from one set. That should allow you to power it up and make sure everything else is good. So that would risk less FETs on the power supply side if there was something else goofy in there. But normally this thing is dang near direct drive except for those gate resistors, and it's got its own power. A couple of resistors and caps right here that we'll check, and I'll zoom in on that when we get to it. So I'll try to keep it simple, try not to bore you with a whole bunch of crap. Like I said, I'm going to snip all these out, and I'll show you a bit of the cleaning, show you how well it cleans up, and then we'll show inspecting. We'll have to double check all the traces, make sure we don't have any broken joints where the power comes in on the bottom here to the FET legs. A lot of times when they blow this bad, they like to blow this little thin part of the circuit. If I can hold this thing, they like to blow. Let's right there. Let's see if I can get the glare off. See how that's got a thinner area right there where the leg and this meet? So they like to blow apart right there. And if that happens, I'll clean that all up. I'll take some braid and I'll fix that and make a good permanent jumper across there and stuff. So we'll get to that once I get it ready for cleanup stage here. So I've got them all pulled out, and I go through and I inspect. And what I'm looking for is, like I said, here in the center leg, normally we get a bust, a crack. It'll heat it so much, too much current. You'll notice a lot of that's thick traces. There's a lot of solder there. There needs to be extra solder on all those traces for the current to help up the current of that trace a little bit, because they run the traces so thin that they need just a little bit. You know, that solder adds more material for heat, cooling, and current capability. But I'll go through with the eye loop and inspect all those and make sure they're good. And like I said, if we repair it, and now you can see how dirty these are. So I'm going to see if I can't give you a little zoom with the camera staying in focus. Just using isopropyl alcohol on a Q-tip and start cleaning, breaking this down. Switch over to the other side, and you can see a lot of this will come off. Really huge amount, if not all sometimes. Keep going after it. A little IPA on your cotton swab. And sometimes not every bit of it comes off with the IP. Sometimes you gotta do a little scratching with a pick of some kind, because see how this stuff can kind of be on there. And sometimes you take a little squirt and you just put a little squirt on there so it can soak. Get a good scrub. And this one's not so bad. Normally, it'll soot up all this so bad. I mean, we're going to clean it all, and it has got soot on it. Like you can see soot on this capacitor. You got to get all that clean. But normally I've had it just black and even all the way up the sides of these so bad and everything. And like I said, this has got some. A lot of this will get cleaned when I hose it down. But this side doesn't even look too bad. This side's got more on this cap here. But you can see over here, we can hit that with a little IPA. And it's going to start cleaning up. There we go, good focus. You'll see some of it cleans up there pretty quickly. Some of it takes a little more effort. But I'm going to scrub and scrub on this. Like I said, I've showed you what you do. I'll get that all cleaned up, and then we will test the, I'll show you the gate resistors here. Most of them will probably have been fried. There's also a couple pull down resistors on one side. This area right here, really dirty, really bad. That's starting to come up. We'll get it all cleaned up, and then we'll go through those gate resistors, and then we'll shoot over to this little chip. You can already see the disastrous effects of blowing your amp. So I'm going to get my multimeter out here and put it on ohms. 200 ohm down here, my smallest setting. And we're just going to go through my glasses so I can see. Turn my hat around so I don't block you guys. But we're just going to go and we're going to check. That one reads 10.2. That reads 10.3. That one reads 31.9. See if I can get that in on the shot. .32 ohm. 1.9. So that one's bad. That one reads nothing. It's so blown. You can see a dot right here in the middle of it. It's just fried. That one reads 34. So already got all of them, but these first couple that are going to need replaced. We get down to here. So I can give you a little better thing. There's only half the chip left on this one. This right here is a pull down resistor. It's 103, so it's a 10K. I can put my reading on to 20K. And it's reading a dead short right now, but that may go away when we do something else over here. So we'll check that. There's two different pull down resistors. There's another one over here. Let's read it and see what it reads. Of course, that pull down may be truly shorted because it's sitting right next to the one that blew in half. So this 10K reads 7.5. But the problem we got here is this resistor. I don't know if I can zoom in anymore and keep it in focus. This resistor, you can only see the tiny tail of it. See, well, there was another one that was right there. It's blown out, and that is actually the fiberglass of the board. It has charred this, so I'm going to have to dig out anything conductive right here. And I'll just do that with a little bit with my tweezers, and we'll just work that fiberglass until it is got all that carbon out of it. And we'll check all the way around it, because it really blew. And so I'll work that area over. I'll check all the rest of these resistors, and I'll replace the ones that need replaced. But I want to get you over here. There we go. So you can see this normally would be the driver chip, and you can see it's got a big old spot on it. This is part of the power supply circuit, and so is this. This is actually the power feeding into it. Goes through this resistor. This is the filtering cap for that and everything. And you can see this little 10 ohm. It's a 100, which means 10 and 0 extra places. If you get into surface mount stuff, it's got a big old dot in the middle of it too. Can you see that dot? See how this one, you can see the 103. That one would say 100, but you can't see the 0 in the middle because it's burnt up also. Now you got this chip, and those are pull downs on this leg and this leg. And you need to check those because they are on the drive circuit that goes out over to the rest of the resistors and stuff. Normally those don't take damage, but they can, just like those other pull down resistors. So definitely going to be replacing this one and this one. Got a helicopter going on. I'm going to go peek. It might be a Black Hawk. Yep, it was Black Hawk. I live close by Springfield here, and there's a military helicopter repair at the airport. And so time to time you'll see a Black Hawk that's been serviced, and that'll go flying over. Pretty cool. So here's what I do on these chips. Anytime I'm going to be hot air removing anything on modern boards, because these surface mounts, because they use lead-free solder, that's a higher temperature. So a little secret to keep you from blowing everything else off the board is to add some leaded solder to all of it. And that'll actually make this chip come off at a little bit lower temperature. Now I know this resistor is bad. A lot of times on the resistor you can heat it from both sides and get her to come off just back and forth a little. If it doesn't want it, there it comes. So got that off. Sweet. Then we'll fire up the hot air. Now that we got some leaded solder on that, it should come out and melt at a lot lower temperature than the components around it. So we're going to general heat around the whole area because we don't want to put a high stress expansion point in that circuit board. All these circuit boards are pretty cheap. So general heating, especially while your hot air station is warming up, if it's not already warm, is just helpful. Get that nice general heat in there so you don't tear up anything on your circuit board. And then we're going to get in here and we're going to start going back and forth on these leg areas just to get it going. Now the other nice thing about having that leaded solder on there is you can kind of tell a little easier when it goes liquid because it'll get shiny. Most lead-free solders are dull. And so bam, there we go. That got removed nice. We got that other resistor. Now I'm going to check for a short across. Oh, we've lost focus. There we go. There we go. Across this capacitor because it could have got damaged. But the other thing we're going to do, come in and we'll clean up these pads, both the resistor and temperature. Tiny tip on. I'm just going to clean that up. We're going to replace it with an MIC 4427YM-TR. I think I ordered more of these. I hope I did, because this is my last one. Otherwise, I'll have to switch to the UCC 27324, which does the same thing. One of them's 1.5 amps, one of them's 4 amp. They're not a whole lot of difference in them. I have to look at the spec sheets a little closer, but they both seem to work. People have successfully used both of them. So if you look, the board is marked with a little notch right here where it says IC3. That little notch is telling you where pin 1 is. Well, on the chip itself, there's a dot right up here by pin 1. So that tells you how that needs to go in there. It needs to go right over there. I'll show you how I solder this in. So I get it pretty good and square in there. I'm old and I shake a little more than I used to. Trying to do fragile, delicate work. So it takes me a little longer to make sure it's all good and pretty. Dead burn it. That and these are just a pain to do. You can ask anybody to try to get it lined up. That's why a lot of them use hot air to put them back on there. I don't like adding the extra heat, especially to chips like these driver chips and stuff, because these are sensitive to moisture. They get any kind of moisture inside, and when you heat them up, they actually destroy the inside of the chip. So it's so much easier to not use hot air. But I'll get a little bit of solder on the tip of my iron, the tip that holds the little ball. I'll get this kind of in place. I'll hold it down with the tweezers, and I'll just get a leg on each side. I don't really care. I'm just trying to get something to hold it in place. Then we come back and we add a tiny bit of flux. And that's where this tip really shines. It'll hold a tiny bit of solder on the end. We can come back in the flux and just touch each leg in succession. That flux will help make sure that it shouldn't make any bridges. If it does make a bridge, clean the solder off your soldering iron if you're using one of these conical tips. And then you can go back through and you can touch it again, and this conical tip will pick up that extra solder and hold it in the tip area. We've got that done. I'm going to do that resistor. I'm going to fix all the other resistors, and we'll be back right after that then. But that'll fix that, and then we'll, like I said, we'll get to these other resistors. I have to clean up this one spot where we got carbon problems, and we're going to have to make a jumper once that resistor is in place that goes over to the gate leg of that FET. But now I'm just going to be pulling off resistors and replacing them. The solder up just the same. I use a little dab on the with the, let's say this was my soldering iron. I'll just slide that resistor in place. Once I've taken all these off that need to be off and clean the pads, I'll just put that on there, and I'll just dab one end, kind of get it in there, and then I'll put a little bit of flux on there and go back in and make a nice pretty solder joint with the flux does. go through and then test everything. I test from the drive side to the actual pin area here to make sure that that didn't burn up like this one did. And so then if you read 10 ohms across there from the driver side over to the gate leg, you know you're good. And this one we'll have to do a little repair on, like I said. Get all that squared away, and then we'll put in some FETs. The FETs should be this, a CSD 18502 KCS for the power supply. So we'll get 16 new FETs in there after I've checked all that. You know, it's just, man, a lot of electronics repair is once you find the fault, is checking things around it. Like we're going to check the, like I said, we check this cap for shorts. Then reading that way, charges it back up. Looks pretty good. So it's just checking and testing. And like I said, you would test in your ohms. We know this one's good. So that should test about 10 ohms across there. If we was to test straight across, it's testing 10.2, but we're making sure we go all the way to the gate pad. And that just ensures that these aren't broke. So a lot of electronics is making sure you don't, when something exploded and died, is, fixing burnt up spots for no conductivity, and then making sure there is connections everywhere. Because if you leave a FET with its gate leg floating and you give it power, it will build a static charge and on the gate leg, because there's power to the rest of the FET, and it will eventually turn itself on, and it'll never be able to turn itself off because nothing will pull that leg back down, the gate leg back. And so it'll just turn on and stay on and blow. And so you always got to make sure that's good. And that's also why you never leave FETs in on outputs if you don't have drive chip setups in them, like on Korean style amps, unless they have a pull down resistor set up, also helping to keep those gates pulled down. Because you take driver chips or the little driver chips out, and then that leg's just floating, it has nothing connected to it, it'll build charge if there's power on these other legs. That's just how MOSFET works. It doesn't take any current to turn these things on. They turn on by just voltage, and they have super high impedance on their gate legs, so they can just actually self turn on sometimes. Not all the time, but they will. And then of course, bam, things turn on and things become short, and boom. So always be careful with that. Of course, always be careful with the rail voltage. This thing's nice and discharged. I haven't done anything to power it up because it obviously had a blowed power supply. But we'll get all that together, and then technically we could just power up one set on each side of the rail for this, because it's got two sets of rectifiers, so one side each, because this little pick chip's going to be monitoring both sides. But technically we could do that and power it all up, but once I've checked everything and stuff, we should just put all the FETs in and then power it up and see if we have any other problems. So you can't troubleshoot outputs, even though these checked all good, truly, until you get some power supply. So I'll get that bit done, put the FETs in, and I'll be right back. Alright, I got all the FETs in, and I'm going to show you, keep it from bouncing around so much. When I get done, go through, put my meter on ohms. Not sure if I get that in there and keep the focus going here. We'll be upside down. And I go from there on the driver's side to the leg. I measure and I make sure I'm getting my 10 ohm resistor. That means I got good connection from there to there. Now, technically, you can measure, just stick it on one of those legs here. hang on, right here. Nope. There. You can measure all the way from the drive chip to make sure it's good. I can hold it on there long enough. This one, yeah, that's the other one. So you can test it all the way from the drive chip to make sure your circuit's good. That just ensures that you did a good job soldering up all those little surface mount resistors, because they can be a little tricky. So that's just good preventative. Now we're going to set that aside. And we got to clean on this mess. And so it's going to be pretty easy. We're going to pick out the big fat chunks. And we're going to carefully get up underneath this piece. And I'll just show you on this here. Get a little paper towel, set it on. Try to wipe away all this junk. Get some IPA going on it. And get another piece of paper towel. Little IPA. Gently. Gentle. This stuff is fragile and brittle. We're just going to get a wipe down on it. Careful not to hang the corners into the paper towel. You'll bust it. Let's see if we can tell. Like most of the deposits are on that side. We get a couple cotton swabs. Just going to gently work our way to dissolving away all that stuff. You can see it's slow but sure will come off there. Now, you may have damage. You may have to replace it. Let's see, we got some damage here. Here we have what appears to be some solder, maybe even a hole. So you'll have to probe around. Yep. There we got a hole. That hole is going to be right where that fit is. These metallic spots where it overheated. So what I'm going to do is clean this as best I can. Like I said, I'll show you those. This blew a hole in it. See that? That's right where that silver area is. We got a couple more. So what we'll do is we'll clean this, and we're going to cut out this section. Use what we can of this. And then have some mica pads. See that reflecting in the light that you can buy. Here was one of the part numbers from DigiKey. So it was part number 36-4672-ND. That'll help you find some of these. Like I said, that'll replace, we use 2 of these to replace that section and that section. And so I'm going to clean. The other thing you have to do, don't tear that up, is come back in here and you'll have to clean all this old stuff off, get all this junk out of here, and I'll have to clean it back to this next section. This probably won't have any explosion stuff on it as far as damage like the other piece did, but we'll just have to clean all this up, and we'll do this other side too. And so bring it back when I've got it cleaned and cut those pieces positioned. Okay, now that we got the board set down in place, we've gave everything a thin skim coat of thermal compound. We're going to make sure that the original factory ones are centered up on the bolt holes down here. Sorry about my head being in the way. I got the hiccups a little there. And that's all good. And then any of the new ones, we're going to make sure that we are centered up on the fet, like this one needs to go to the left quite a bit, and same with this one. And every now and then, you'll have a fet that you didn't get perfect. Where's my better? There they are. I use some flat pliers. Reach down and you just give it the slightest little wiggle lean, then recenter up. Like I said, I got to get down in here so I can see because I'm old. Crap. But you need that setting completely under the fet, all lined up, so that it's the insulation between the power tab, the metal tab gets power through it, and the frame of the amplifier. We don't want a short circuit. And you'll notice I trimmed off the oh crap, there we go. The ones I had, because they've got this little place where you can actually bend the legs and put it through, so I just trimmed that off so I could get this stuffed in far enough, right up against the edge of the board, basically, is where all these are going. That's just how they have fit their stuff. And we got that all centered up. A bead of something. Always try to keep everything as clean as possible when you're doing all that. I do see dirt in the middle of the circuit board that I didn't see before. A little bit dirty. Rub off very good or not. Hear the dog slurping in the back. She just got let in. All right. Now I'm going to clamp these down and either steal some clamps out of another parts amp or make a few and get this all bolted in, and then it'll be ready to test. Gonna get bolted up. Okay, so to power these up, put some power and remote to it. Hook up a speaker because you're going to be powered up, and I went ahead and slapped the RCAs and got my radio ready just in case. I'm going to see if I get a little zoom so you can see these LEDs. I always use my current limited supply. It'll only produce 3 amps maximum to pulse this. This style, because it's got the pick chip, will do a power test and it will not let it power up. The blue light will flash and the yellow light will stay on, but the protect light will go away. But it will not power up because it's too little of current and you have to turn on your big supply. So I've already done that, and I just do that test to make sure that we don't immediately spike out at 3 amps and something's a dead short that I need to be looking for. If you accidentally forgot to put in one of the insulators between the FETs and stuff and everything. So now I've got my bigger supply hooked up. Hopefully you can kind of see that. Let's see if I turn off the overhead light. See them all come on, and then all of them should go out, and only the blue one should still be on. And that would be fine. If the yellow is flashing, that means you still have a problem in the output circuit. It's not getting the correct feedback. The clip indicator tells you that. But we should be able to play some music. That's awesome. So she is working. Hope you learned a little bit, seen how I did some of the stuff, know how to lightly coat, your thermal paste and all that other good stuff. Fix it up. If you're learning amp repair, don't get a high-end amp that you really treasure, or an old school one that you really treasure to learn on. Buy the cheap junk. Anything you can find, you should be able to get it. Shouldn't actually, technically, don't buy a thing. You should be able to hang out with enough dudes somewhere. Somebody's going to have an old amp that you can, they'll give you, and that you can learn on. That's junk, off-brand, and just, start poking around with your multimeter and learning. But when you get, start to get advanced, I hope these videos help a little bit. I'm not an expert by any stretch of the imagination, but I can repair a few things. So hope this helps. Hope you enjoyed watching it. Like, comment, subscribe. Really helps. Thank you very much, and see you next time.